Hello everybody, welcome to my very first video on this YouTube channel, and for this video we're going to be making a self-balancing platform. Now this video is inspired by HowtoMechatronics. Now for this video I 3D printed some parts. This is the base. Here, this is the base. These are the holders for the servos, and this is the platform for the self-balancing. This is the cover after we're done setting up everything, and these servos here are the MG996R servos. You need 3 of them. I ordered them from Amazon. The parts will be in the description below. Then we'll need a couple of M3 nuts and bolts. Yes, that's basically that. Now the 3D parts were printed with an Ender 3 V2 3D printer right here. And a printer with very good quality. The print time in total was about 1 day, or probably around 20 hours to print all these parts. I decided to add a time lapse for one of the 3D prints because it looks pretty cool. So to start off, we take our base, then take one of our servo motors. I inserted it into the base. See the compartment there? I inserted it into that compartment. Then I took M5 screws and inserted into it. Now if I turn it around, it took quite a lot of time, but I was able to get the M5 screws into it. I can use the nut to fasten it. I have to be careful that the screws don't remove. So after a while, I was able to get the nuts and bolts in. We're going to do the same thing for the pitch and roll servos. We're going to use the round horns, which came with the servos that I bought. So they look like this. So what I did was I punched holes. The holes were initially small, so I punched holes into them to allow the M3 bolts to go through them. So I'm going to take this, which is slightly longer than this one. I'm going to fasten it to, fasten a round horn to it using the M3 bolts and nuts. As you can see, it's fastened to it. I'm going to attach this to the servo on the base. You can see the type. You can see it turning. You can hear it turning. Excellent. Now for the base, we're going to attach the round horn to it just like we did for this one. As you can see, it's moving. So that part is set up. I'm going to do the same for this one. So actually, this one doesn't go here yet. Instead, it's gonna come onto it. Then we'll have this one here. Then this here is just for cable management, so I pass it through this. So there's a final look of it. I haven't yet added a battery to it, so what I'm going to do is I'll set it up on the breadboard. I'll set the Arduino up on the breadboard, then test it first. But before that, I add my MPU 6050, which I solder headed pins on, and these wires. So it will go through these small holes here. Excellent. And buy a flattener like this. Now I'm just going to pass it through this. For testing sake, I'm going to pass this. Now on to testing. Now I've connected it to the breadboard to test if the servos work alright. So this is the setup. Yeah, it's connected to the Arduino Nano. Now to test if the servos work, we'll try them one by one. So let's see. Okay, so that servo works. Okay, the servo works too. I mean, yes. Okay, it works. Okay.
Hey y'all, come look at this.
Okay, it's moving quite well now. Let's forget that happened. We are good to go. The code for this is simple. For the MPU, I'm using the MPU 6050 Lite library. I found this to be the most stable library for the MPU 6050. These are how I created my servo objects for the 3 different servos. Here's me attaching the pin digital pins for each servo, digital pin 3, 5, and 6 for each servo. And this code here is to initialize the library for the MPU 6050. And here I use a map function to map the MPU values to the servo angles. So it turns depending on the MPU orientation. Then I write to each one of the servos, and that's it. So the code has finally been written. Now to test it out. Okay, it's going quite as well. We're doing some deviations. Let's try and turn. Not perfect. Let's try going down here. Okay, we've tried it. Try going down here. Okay, that's actually perfect. Steps. So overall, the platform is able to self-balance, although it's not perfect. That's it for the video. Thanks for watching.